One of the most confusing parts of acceleration is that there are two units of time. So when you see an answer that has something like 10 meters per second or 1 mile an hour per second, it looks weird because we're used to velocities where there will only be a distance unit and a time unit. But now with acceleration, there's two units of time, so that gets kind of weird. First thing, you do not need to convert hours and seconds to be in the same unit. Don't do extra work. Don't try to change miles an hour to miles per second so that it matches with this or anything like that. No need to change anything. You can have two units of time that are different from each other, like in this instance here. So what does this all mean and where does it come from? So it stems from the acceleration equation, where we calculate acceleration by subtracting your second velocity minus your first velocity over time. If we think about velocities being a distance divided by a time, and then we're dividing that all by a time, you see where we have our distance unit, a time unit, and a time unit, right? So we'll have 1 unit of time and a second unit of time here, which is how we end up with our distance unit, a time unit, and a time unit up here. So I would suggest that you read it a little bit differently than just 1 mile per hour per second. I would actually add a little bit of a pause here. So I would read it as your acceleration as 1 mile an hour per second, or 10 meters per second. So that little pause between the first and the second time here indicates something to you. So 10 meters per second. So what that means is, if we're looking at the 10 mile an hour per second here, it tells us right here, this piece tells us the size of the jump that you're making in acceleration. And the second time tells you how long the period of time is that it takes to do that jump. So what this tells us is that every single second that goes by, you're going up in speed by 10 miles an hour. So every second you go up by 10 miles an hour. If you're going up by if you're going up by 1 meter per second, that means that every second you're going up 1 meter per second faster in speed. So after a second, you'll be going 2 meters per second, then 3, then 4, then 5, then 6, then 7, then 8 meters per second. So the longer that you are allowed to accelerate, the more seconds that go by, the faster your speed will be. And it's going to go up by jumps of 1 meter per second. In this option over here, for every second that you accelerate, your jump is going to be 10 miles an hour. So that's why I suggest reading it as 10 miles an hour per second, or 1 meter per second. That just little pause indicates that the first half of it is your jump. The second half of it is the amount of time that it takes to do that jump. So one final little piece here is how 1 meter per second equals 1 meter per second squared. So if you see either of those two answers, they're not different, they're actually the same thing. And the reason for that is just looking at some rules of math. If we take 1 meter per second and divide that by a second, remember that dividing by a number is the same as multiplying by its inverse. So if we actually have 1 meter per second, right, which is what we're saying here, that is the same thing as saying 1 meter per second times 1 over s. Multiplying by the inverse is the same as dividing by a number. So now if we finish this equation out, we've got 1m over s times s squared. So we get from 1m per s to 1m per s squared. So they're the same exact thing. So to sum all this up, why do we have 2 units of time? Because we're talking about achieving a certain amount of velocity, an increase or decrease in velocity, in a period of time. So the first distance in time tells you how big your jump is, and your second unit of time tells you how long it takes to make that jump. So the bigger that this number is, the larger the jump is going to be. Whatever unit of time is here, seconds, minutes, hours, whatever, that tells you how long it takes to do that jump.